So now we're going to graph this example here. Okay, f of x equals to negative 4 to the x power. We know, of course, that the domain is going to be from negative infinity to infinity. Okay, and the first thing I'm going to do is I'm going to address something very important. You might be thinking to me right now, David, there's a negative sign in front. So is this even a exponential? Right? You said to us, David, that an exponential will be f of x equals to b to the x power, provided that b is strictly positive. Okay? Right? And you might say to me, David, what gives? Here you have negative 4 to the x exponential, right? That's what you're thinking in your brain. So now, again, we know that we need to abide by the order of operations, or at least these are the rules that we've accepted to use as our guides when we're calculating, as how these operations are to be performed in what order. So if I look at this expression, I can look at this as, we know that negative of something is just negative 1 times that something, like this, right? And so if that's the case, then what this actually is negative 1 times 4 to the x power. And now you might say, okay, David, that doesn't change anything. Is the 4 positive or is it negative? I mean, is the base positive or is it negative? Well, if I want to evaluate this expression at any value of x, I will have to perform the exponent first before I perform the multiplication with the negative 1. And so that means that what's going to be raised to the exponent is going to be the 4. And only after that will the result be multiplied by negative 1. Okay? So this expression, in other words, negative 4 raised to the x power, is the same thing as negative 1 times 4 to the x power. Okay? But you usually won't see it written like that. You'll see something written like this, and I want you to know that that is the same thing as this by the order of operations. Because the 4 will be raised to the exponent first, long before it's multiplied by the negative 1. Okay? However, I do want to point out, if instead of this, it had been negative 4 to the x, then this would not be an exponential. Okay? This is not an exponential. Right? Okay, this is not exponential, because then the base would be negative 4. And it would be negative 4 being raised to the x power. Okay, so this would not be an exponential, but this is an exponential because this is in fact identical to negative 1 open parentheses for the x close parentheses. Okay. By the way, this is another reason why parentheses are so important, because, like, for example, for my own part, even though I'm writing this example like this for us, I'm writing it like this to make this point. If I was writing down an exponential like this with a negative coefficient, I would make it explicit as in this form, so that the reader of whatever I'm writing will not make a mistake. Okay. And so with that little bit behind us about why this is an exponential, we can begin to actually talk about graphing. Okay. And you can already imagine that here I'm going to pick some numbers for our table that are going to make our calculations particularly nice. Okay. So let's do that together. So 0, 1, 2, negative 1, negative 2 as my x's, and as my f of x's. Okay. Now, by the way, I want to make a point here that's very, very important. Even though in the last couple of examples, in this example and in the example that follows, I'm using the x values negative 2, negative 1, 0, 1, and 2, I don't want you to think that you should use these all the time. This example has been chosen and these numbers have been chosen to make our calculations as simple as possible so that we can draw a nice portion of the graph with as little fuss so that we can gain the most insight from it. Later on, we're going to graph more complicated examples, and we're going to look at those graphs from two possible perspectives. In fact, we're going to look at them from both perspectives, but we're going to do when we do that, we're going to do one example in the first perspective, and then do the same example in the opposite perspective. In what are those, and in doing that, we will see how to construct a table, either by explicitly choosing x values to make the calculations nice, or by getting the table by another means via transformations that we'll see when we get to those more complicated examples. But what I want you to know is this: don't think just because we're using the same x's here that you're always going to use these x's. Okay. Okay. So now here, let's start evaluating this table. Now, after the two previous examples, we have seen a lot of the exponential rules, and so I'm going to assume those as we go along here in this calculation, and pues let's do that together. So let's look at -2 first. The f evaluated at -2 is going to be -4 raised to the -2 power, okay? And we know that that is nothing but -1 times 4 raised to the -2 power, based on our discussion before about how the order of operations comes into play here. But what is 4 to the -2? This is going to be 1 over 4 to the +2. Why? Because remember that x to the -n is equal to 1 over x to the +n. Okay. Now, what is 1 over 4 squared? Well, I know that 4 squared is 4 times 4. Why? Because it's 2 copies of 4 being multiplied together. 4 times 4 is 16. So it's going to be -1 times 1 over 16. What's -1 times 1 over 16? -1 over 16, like this. So that's my f of -2, like this. Okay? So now we're going to calculate f of -1. My f of -1 is going to equal -4 to the -1 power. That's going to equal to -1 times 4 to the -1 power. And then this is going to be -1 times, what's 4 to the -1? 1 to the +4 to the 1 power, okay? But of course 4 to the 1 power is just 4, so I can just write it like this. And then -1 times 1/4 is going to be -1/4, like this. Like this. Okay? Okay. Now, I want to calculate f of 0. So what is f of 0? F of 0 is equal to -4 to the 0th power. But what is that? That's going to be -1 times 4 to the 0th power. What's 4 to the 0th power? That's 1. So it'll be -1 times 1. By the way, so why is it 1? Because we know that for any non-zero x, x to the 0th power is equal to 1. Okay? Okay. What's -1 times 1? -1. Like this. Okay? Okay. Now we want to calculate f of 1. Okay? Let's do that together. F of 1 is going to equal -4 to the 1 power. We know that this is going to be -1 times 4 to the 1th power. We know that 4 to the 1th power is just 4, so this is going to be -1 times 4. What's -1 times 4? -4 power. I mean -4. And of course, if you do f of 2, you're going to get -16. Okay? Let me do that for you here real briefly, just so we can be totally like complete. Okay? Okay. So f of 2 is going to be -4 squared. which will be negative 1 times 4 squared. That's negative 1 times 16. Why is it 16? Because what is 4 squared? It's 2 copies of 4 being multiplied together. Okay? And so negative 1 times 16, that's going to be negative 16 like this. Okay? Okay. So now look at what's happening here. This is very interesting. Right? So for some reason, all the values here, all the y values are negative. Right? Did we make a mistake somewhere? No, we didn't. Okay. So the first thing, so before I actually draw the graph of this, I want to remind you of an important fact. Okay. So I know that if, let's say if g of x is some function, okay, comma, then if f of x is equal to negative g of x, comma, then f of x is the reflection of g of x across the x-axis. Okay, so this is an important fact that we learned from our function transformation discussions. And so, and by the way, so let's look at what's happening here. Or wait, no, I'll get to that in a moment. But so we know this like from our function transformation discussion. Okay, we don't need to have this discussion right now, but I just want to segue into this. Okay, so we can get some insight into what's happening here, or get some insight from a different perspective. Okay. 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 So look, the f of x is negative 4 to the x. Okay. And from our discussion, we know that this is actually the same thing as negative 1 times 4 to the x. Okay. So if we were to let g of x equal to 4x, then it would be negative 1 times g of x, or in other words, just negative g of x. Okay. So if g of x is equal to 4 to the x power, f of x is its reflection across the x-axis. Okay? Now, you can very easily make a table for my g of x, and I'm going to do it here, but you can verify it on your own, because, of course, the numbers here are designed to make that very easy. Right? 4 to the negative 1, 4 to the negative 2, that's 1 over 4 to the 2, that's 1 over 16, that's that. 4 to the negative 1, that's 1 over 4 to the positive 1, that's 1/4, that's that. 4 to the 0, that's 1. 4 to the 1th power, that's 4. 4 to the 2 power, that's 16, because 4 to the 2 power, that's 2 copies of green multiply, that's 16. Okay, okay. So if I were to graph this here, you will see that it's going to look like this. Okay. Right? And what would it mean, the horizontal reflection? What would it mean, the reflection across the x-axis? It means I take the xy plane like this, using my x as the pivot, and I just go boop. And so I would get a graph that looks like this. Well, roughly like this. It should be identical to this one, just flipped over. Okay. If I had a transparency, we could make that happen. And so in this case, this is f of x equals negative g of x, or in this case, negative 4 to the x, and here this one was g of x equals to 4 to the x power, okay, where f of x is the reflection across the x-axis. So there are several things I want us to notice about this. So first of all, if it is the reflection across the x-axis, then the range, which in the case of 4 to the x was from 0 to infinity, the range now will be from negative infinity, okay, negative infinity all the way up to 0. So that's going to be our range. Because of course this is our graph that we're looking at. And the horizontal asymptote, if for 4 to the x, if the horizontal asymptote was y equals 0, then if I'm just rotating the whole graph about y equals 0, then the reflection will come upwards towards the x-axis, aka the line y equals 0, as x goes to negative infinity. Okay? And so we know that the horizontal asymptote will still be y equals 0. Okay? Okay. And what else did I want to tell you? Oh yes, and then if you look at this graph, you can see that it reflects all the facts we see here. As I go negative, right? As I go more negative, the magnitude of the numbers is getting smaller, but they're negative. We can see that that's true. So in other words, what we're saying is that the distance of the graph from the x-axis is getting smaller and smaller as we go leftwards, but it's still it's coming in from the bottom because they're negative. And similarly, as I go off to positive infinity, as I move to the right along the graph, the negative 4x, which is this picture here, goes down to negative infinity. Right, it gets bigger and bigger and negative. And we can see that that's exactly, so in other words, the pattern we see in the table, we see it here in this reflection across the x-axis of the graph 4 to the x power. Okay? Okay. So I just wanted to show you how we could use the transformations to gain insight into this. But this discussion is not strictly necessary at this time, but I wanted to throw it in there for completeness and for like a little bit of, for us to see those ideas being applied before we use them in the more complicated examples. And now we're just going to do a graph using our points of the negative 4 to the x graph. Okay. So here, the graph is going to look like this. This is my x-axis. If this is my y-axis like this, I mean my x-axis, this is my y-axis. And let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And then, oh my God! As I just did those 2 tick marks, I thought in my brain about the blue Danube Waltz by Strauss. I was like, dun 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 dun. No, I'm just kidding. Couldn't help that. I was like, it's because I just heard it in my brain as I was doing it. Dun dun. Okay. So let's graph this together. At x equals 2, the y is negative 16. So if I'm over here by 2, I go down over here. If I'm at x equals 1, I'm at negative 4. So x equals 1, I go to negative 4, right there. Okay. At x equals 0, I go negative 1, here. At x equals negative 1, I'm down 1/4. So I'm going to be right there. Right? You can imagine that if I slice this into quarters, like that, you see? And then at negative 2, I'm at negative 1 over 16, so it's going to be much closer to the x-axis. So you can imagine that it looks like this. Okay? Like that. Okay? Now, I shouldn't wave like that. It should just be like this. And of course, as it goes this way, the graph is getting closer and closer to the x-axis. It asymptotes to the x-axis like this. Okay? And of course here, you can see that, and let me make a brief point. If you remember from our discussion, we saw that um, like uh, like this was the g of x equals to 4 of x, right? And we saw that this was the reflection of 4x across the x-axis. So in this case, we see that this b, the 4, is greater than 1. And we saw in our first example that if we have b to the x where b is bigger than 1, then the b to the x is strictly increasing. And that means that that if x1 is less than x2, then b to the x1 is less than b to the x2. Okay? If we reflect that across the x-axis as we've done here, we can see that this function will be strictly decreasing. Okay? Why? Because if I take because for the x, so because for the negative, because here in this case over here, if x1 is less than x2, then 4 to the x1 power, 4 to the x1 will be less than 4 to the x2. Okay? What happens if I multiply both sides by a negative? That switches the inequality. So here, I know that if x1 is less than x2, multiplying this inequality by negative 1 on both sides, it switches the inequality, and I get negative 4x1. Oops. Sorry about that. Negative 4 to the x1 power is going to be bigger than negative 4 to the x2 power. Okay? And so you can see that in this case, in this reflection across the x-axis, this function, the negative 4x, is strictly decreasing. Okay? In any case, I think we've said everything we have to say about this particular example. And I hope you've enjoyed it, and I look forward to seeing you soon. Thank you so much.